Class is now starting. All attendees are in listen-only mode.
Hey, Patrick. Can you hear me? You can type and stuff if you don't have
Can you hear me?
I also might not have the volume on.
This is Lawler.
Oh. Cool. Can you see my webcam by any chance?
Negative. I don't know if you can hear me yet. No.
No. No, that's fine. Yeah. That's cool. Can never get the entire thing to work at once. Can only get like most of it to work. Oh. So we got 5 more minutes? We get 5 more minutes. All right. So we got some East Coast, West Coast. Looks pretty good. What I'm going to do is I'm going to record this, and then I'll put it on YouTube. So if you know somebody who wanted to attend but they couldn't, they should be able to watch it after the fact. Also, I'm going to have the questions pane up. So if you want to ask me something, you can. I'll look periodically. I'm not going to look at the raised hand thing. I always thought that was kind of dumb. But I'll have questions up. Okay. So, thanks for attending. This is all just a demo, something I've been working on for the last year or so. That's one of our new tools in Pydro called Scribble. So Scribble is sort of the final piece in what I was thinking of in terms of like the data processing workflow as a whole, and it's like the project level information gathering thing plus reports plus DRs plus all that stuff all sort of in one. And I was thinking that would be like the last little gap in our tool set that we don't really have anything currently for doing. I know all the ships have like their own methods for getting reports and templates for DRs and that sort of thing. So I'm hoping this will sort of combine a lot of that into a more automated sort of tool set. So like with all of our other stuff, I've got these docs on the right, and they sort of talk about the different sections of the tool and what I'm doing to get the stats and the information for those. Nothing too exciting. Okay, so I'll go ahead and run it. While it's starting, I'll mention that there's two big like prerequisites here. One, everything in here relies on those NOAA INI files that you use when you process in Charlene. So your project structure, and I'll show you a little bit more later on, the project structure has to be in the right folder format structure thing. You know, like the NOAA _ 2018 INI that you use in Charlene, like has to be the right, everything's gonna be in the right place or else I can't find it. And the second thing is that the screenshots and the statistics and things all rely on base editor. So you have to have Keras base editor installed and licensed. Okay. Is this too small? Can you guys see this? I can crank up the resolution if I have to, but I figure this would be okay. It probably is. Okay. So what you get when you first start it up is the project structure check. So we'll talk about, you know, the basic idea of the tool up here, and on the left there'll be some more like help text. But this is the main pane right here, this notebook with these different tabs. So the first tab is sort of like it's like a project dashboard, is what I'm thinking. You point this button at the project level directory. So this will probably look familiar, right? This is your like spec structure. So you point it at the top level. If it's split and you have like a raw and a proc, like your NetApps, or there's two, there's like an H drive and an I drive or whatever, you can point this at the raw side. So you can run this even if your project split between two directories. And if it's set up correctly, you'll get a sheet listing here of all the sheets in the project. You just pick the sheet, and then you run this check. Looks good. Thanks, Matt. So what this is going to do is it's going to look through all of the vessels days in your project, and it's going to check processed and raw directories to see if you're getting the right number of files, and if they're in the right place, and if they're named the right thing, that sort of thing. This is kind of a pain because, you know, with Keras 11 and there's no vessel day folders, keeping track of lines has become a little bit more difficult. So this does some database stuff with HIPS file to check which ones are actually associated with which day. So you can go in here and you can query a specific vessel and a specific day or something and see, okay, you know, here we have SBETs and raw POS files. Here we've got nothing, so there's nothing for this vessel day, which might or might not be a problem. And then here we find that there's no SBETs for this day for some reason. You can check multiple services. These are all like test things, so it's angry because all the names are just not correct. But this will check for naming, and there's even like a little feature file thing. So if you have like a final feature file, it'll look for attribution. If it finds that you don't have any of them labeled new update, etc., it'll tell you, and you can use that as sort of a progress for your feature file. And then if you leave this at the top level, most of these messages like this one, it says it's unable to find SBET for 2 days. So it'll tell you a little bit about how many days it found a problem with in that specific category. So I've shopped this around a little bit. You actually find a surprising amount of issues if you're just looking at like a final project. You know, it might be a 1 day that doesn't have SVP files because they're in the wrong place or something. You know, there's a lot of files that we have to manage, so it's easy to put things in the wrong place. So this has been somewhat useful there, and also sort of a way to track progress in different vessels and things. So I'm kind of just throwing stuff at the wall and see what sticks, see if people use things. You could use it like every morning or something after night processing to see if the last night went okay or something. All right. So that's the gist. If you run it and it finds there's a problem with the structure, this will just say bad, and I think these will all just sort of skip and tell you that you've got a problem with the structure itself. And it'll tell you which folder is missing too, I think. Okay. So the next one is this quick Excel report. This one is kind of similar to the project check, except it's a little bit more static and it gives you miles. So if I look at this project, this sheet, you'll see this cross-line identifier. We track linears, you guys know this, but we track linears according to cross lines, not cross lines, you know, the main scheme cross lines, split stuff. So this will check for your processed folders to see if it's got like an _X or an _XL, or I think I show you. Yeah, it checks for all these. And you can also just type one in. If it's _XX or something, you can just type in like _XX and it'll look for those as well. And if you auto-determine, it'll go through your structure and try to find the right one. Yeah, so there's no cross lines here, so it's not going to find one. And then these are your surfaces. I'm picking like an 8-meter surface just because I want to have this finish in the near future. So as a small example, this will give you your square nautical miles. All right. So if I run this, it's going to ask me where I want to put it. I'll put it wherever. And then you can see it's going to do all the stuff that I have to do to figure out Keras 11, Keras 10 differences and where things are pre-track lines folder and all the nonsense that went into this last year of Keras. And then it's going to go through each day, calculate the linears, and some other stuff that I'll show you. It's going to take your surface, it's going to build an image, it's going to look at the extents and do the statistics to do area to get square nautical miles. It's going to do that for both main scheme, cross line. This should work with side scan too, all this stuff. Okay, and then it gives you this report. So you can see that we have 3 days. So this top section is day, broken off by vessel, and these are your linears. There's no cross lines, so there's no difference here. And then here's your linears by vessel. Here's the total linear. Here's your surface square nautical miles. And then again, here's your feature with a breakdown by feature type, how many you're seeing in different categories. You can look and see what's not addressed, and then know there's a problem there. If you, sorry, you can look and see what's unknown, and then see if there's a problem there, and see if you get the right number with the remarks and recommendations like you think. Okay, and then the next tab is a detailed line query-esque thing for all lines in the project. You'll see it's color-coded, the outdated flag. This isn't the outdated flag that's in Keras, because I found a number of times when you would like load everything, go back, reprocess, and load like TrueHeave or something again, and it wouldn't actually flag as outdated for some reason. Like I found little instances where the Keras' outdated flag didn't seem to be like 100% accurate. So this should actually be probably more intensive than Keras', at least in terms of keeping track of things that have been loaded post georeference bathymetry or merge or whatever. Anyway, I have it on my list to have like a count up here to say how many are outdated, because if you have a real project, this is going to be like 1,000 lines or something. So if you have side scan, it'll do the same thing here. It's not quite as useful, but and then here's the breakdown by vessel day. So each vessel day will have a tab, and it'll have the whole detailed line query thing. It's all based off of the, I don't know, what do you call it? Now I'm blanking. Progress? No. What is this thing? For some reason, blanking. It's process log, yeah. It's all based on this Keras process log, so things are in order of how they arrive. And so I'm parsing this to get these fields and attaching that to like a database query to see which line day is associated with which record and things. Okay. That's the quick report. I'm talking to Megan, who I think is on here. Yeah, I was talking to Megan a little bit about how we can use this to better integrate with the metrics that you guys have this in HSD. So we are looking at that, and hopefully we can come up with something that'll make it a little bit easier for gathering these metrics. But even in upfront, I think this will be better than trying to get linears and detailed line queries out of Keras with giant projects, because that is a pain, I'm well aware. All right. Yep. So we close this. Okay, so now we get to what I've actually been working on this past year, because it turned out to be rather difficult, and I got stuck a couple times. It's a little bit fiddly. So this is my effort of taking a project and generating a DR from it, or at least as much as I possibly can. So in here, you'll see all of the things that you saw previously in some of these other tools. Excuse me. And then all of the project level stuff. So for instance, in this test, I'm including 2 charts. So I've got my charts. I've got 2 charts that are relevant. I have my sheet limits. I've got my main scheme, surface, crossline, surface. I'm going to do like a junction. You can do multiple junctions, but we're just going to do one here. And then down here, you have 3 sections currently. I'm probably going to expand this when we figure out that we need more things, but for now, it just takes in your data and generates, it generates the screen grabs for like your basic stuff, which I'll show you what that means later. It'll do the junction stats, which is the same thing as what compare grids does. So if you're used to running compare grids, this will essentially run compare grids for you. And then it also does the crossline stats. I know that this is, I've been using single res surfaces, which doesn't really represent what you guys do in terms of submitting things. This works with VR, and I'll show you an example of a finished one in VR later. But that one takes like 9 hours to do, so I don't want to do this and, show you something that takes 9 hours. This should only take like 8 minutes, I think. It's a small example. Okay, so I'm going to run it, and then I'll explain while it goes. So what you get is very similar to what the Excel report does, because you need that for your DR anyway. It's going to take in process logs, Charlene logs. It's going to take in your HTCS data, and it's going to build the miles and stats and vessels and whatever from your project. It's going to do that. You'll see up here, you'll notice that it did license check things. So I pull those routines in. Yeah, it's going to get your squares, generate those. And okay, so now it's getting into the actual DR dump side of the program. So it's going to start looking at building images out of things like your surfaces and your charts. What this is going to do is take raster versions of your charts, for instance. It's going to reproject them. It's going to crop them. It's going to turn them into color banded files that you would actually use for generating real images that you can see in Windows, and not like floating point TIFFs and things that you get when you export from Keras. And then it's going to arrange all those things, put title bars and things on top of them, align them with coordinate system projection, and then you get something that looks like this. So this I just created this from Scribble. You can see it's a pretty high resolution image of the actual data set, and it represents the coverage area. This is just stuff that you put in the Scribble to tell it the project sheet, whatever, and all the usual chart elements. You'll see, right, this is the boundary between those 2 charts. and I do some cropping to generate the neat line version of the chart so that it displays correctly and it doesn't look like, it doesn't look like garbage. So these four represent the basic. If you do the basic screen grabs, it's these four things: coverage, density, sheet, limits, and uncertainty. And it looks like that. This is a digitized. I forget what I downsample. It's a digitized version of your sheet limits shapefile. Okay, so it just ran compare grids. So you recognize these probably. These are the output of compare grids. Right, so now it's going to start pulling images out of that and generating your cross lines overview. It's too fiddly. Right, so you have the cross lines overview, the separation difference. It does all the stuff from compare grids. It'll show you, right? It'll do these zoomed in views. Here's a zoomed in version of the previous on the area that has the maximum amount of deviation from the main scheme surface. Here's a zoomed in of the area with the max uncertainty. And then, yeah, an overview of allowable uncertainty. I figured if you wanted this, but you wanted to maybe like zoomed in more on a specific area, I was gonna like under zoom. I was gonna err towards that side because now you can just zoom in. And if you really want, you can just take a screen grab of this and then put your own labels on it. If it's cut and paste, move this down or something. I don't know. I think it's probably better to err on that side. This is a standard. This is like it's not really standard. It's a dynamic buffering between these limits. I forget what percentage, but it scales along with the size of your survey. So it should always be roughly this zoomed out, unless it's real small. If it's real small, I won't zoom in too far because then the chart looks like garbage. So I try to balance that. Anyway, so I just did compare grids on the junction. So there's my junction. I think it's, putting out the junction overview. If you're curious, these were all GDAL routines. So I basically built a routine for cropping things and colorizing things and reprojecting things and scaling things. And I just put all these building blocks together to make this happen. So it's running a million routines to get these things to work. Okay, so here's my junction. And again, if you don't like the zoom, it should be pretty high res. So you should be able to zoom in and get the zoom that you want if you really want to alter these after the fact. These should be random colors. I just picked random colors. Maybe I should put a label down here, which surface is which. I can look at that. So after I finish this junctions, this should be done. So this should be almost finished. You see, you're up to like 7 minutes or so. What you find is that me building images from surfaces for really big surfaces and moving those around and cropping and copying It just takes a long time. So if you have a real survey that's like, I don't know, how big was, let's see how big the one that I ran that took like 9 hours was. So, yeah, I've got a service that's like 17 gigs or something. So yeah, if you have a surface that's 17 gigs, this process takes like 9 hours. So just, run it overnight or something. It still should be easier than actually writing a DR, which I guess is the next part of this. So I did say I wanted to show you, right? So here's the VR run on that 17 gig service. I do all the same operations. It should look basically the same. What I do with VR is I take the courses grid resolution. So you get some like weird artifacts that are just sort of issues with raster images of VR surfaces in the first place. I guess in this instance, courses grid is probably not coarse enough. And then there's the stats. So it generates all the same images. But yeah, it's possible that we might find the VR thing. It's also a topic of discussion that we've got here in the lab about how to handle this. So it's definitely not just a Scribble problem. So we'll probably improve that here not too long, hopefully. Okay, so the final part of this is DR part. And I saw that Toshi might have put in schema change, so hopefully that doesn't break my thing. I'm hoping. Okay. So if I run DR, XML DR, and I generate a new descriptive report, and then I go back, let's look at the one that I ran. Okay, here's a new DR. If you look at like the folder where it puts out all these images, excuse me, you also see a spreadsheet, the quick Excel report, whatever, it ran that too, so it automatically sort of generates that here too, which you can use, which I use. But you'll also see this sheet name underscore drdump.json file. So if you go into DR, you should see under descriptive report an import from Scribble button. And if I point that at, is that the right one? Yeah, the drdump.json, and I open it, and I double check. Yep. You'll see a couple weird things about the images that I'll show you. It's chugging. There's a lot of stuff here, so it takes a second to actually populate and show. Okay. You have me worried there. Yeah, no errors. Looks good. Okay. So nothing too impressive here. Most of this should be populated anyway if you just import from your project instructions. But I do fill in like the start end date, right? So that's filled in from the metrics because I know how many days, because I just did the Excel report thing and I show you. This is what we imported, this JSON file. So all your data is also in here. If I go down to like area surveyed, right, here's your sheet limits. You'll see that I start looking at template text. This is all new, so I populate all these things. There's the images with captions, right? More template text, more images. Here's all your stats. So you recognize these from the quick Excel report. So I push them all in here. I recognize the hull ID from the days presented, so I know the hull identification number or the boat, whatever, length, draft, etc. So I fill that out. I put in some, right, here's all your compare grid stuff, the template stuff. With all the templates, what I've done is, right, there might be areas where I can't, follow the template in an automated fashion. I try to highlight it by doing this little asterisk caret symbol. So if you search for this grouping here, you should get every instance of where I want you to look at and fill in the next thing. All right. So here's one. You get the gist. Yeah, I don't think there's really anything too crazy. I can't reach it. There it is. I put in some more stuff here. Again, templates, the stuff that I can answer from just looking at your data. And that's about it. So I'm thinking that's going to be, it's a little bit of a difficult problem with the images and things because, well, VR makes it tough to make a raster image, and also because they're a little bit subjective. Same with the template text. Most of it came from something I have from the Fairweather for how they're using the template stuff for DRs. So there's probably a bit of a West Coast skew. I tried to remove that wherever I could. Maybe in the future I'll have multiple templates you can pick from. That's probably a good idea. But it should provide just a basic head start for filling out your DR. So that's it. Scribble. Any questions? Oh, I got one. Hold on a second. How do I expand this? This interface is terrible. Oh, thanks, Bashcore. Appreciate it. All right, cool. Well, you know where I live, so if you have any questions or problems, it's still kind of a new tool, so you might run into some issues. Scribble, you're looking at your Dapper. Yeah, the equipment thing. Right. I haven't really looked at the Dapper too much. We were kind of hoping the HighBase thing was going to solve that, but HighBase turned out to be a little bit difficult. product to keep up to date and use, which makes sense. It's like a web interface, and yeah. But the short answer is probably not. I'm probably not going to be providing the connection between the dapper and the DR. Yep. Okay, cool. Well, thanks everybody. Thanks for calling in. Again, I'll put this on YouTube, so if anyone else wants to look at it, they can. All right.